Welcome back. In this video, we're going to learn about percent yield. We're going to calculate the theoretical yield of a chemical reaction and evaluate the percent yield based on the actual amount that we obtain. So what are we talking about when we discuss the percent yield? The theoretical yield is the yield of the product that we would make when the limiting reagent is completely consumed and converted to products. In previous videos, anytime that we calculated the amount of product that we could make, that maximum amount, that's our theoretical yield. So from this chemical reaction we saw, the ethanol reacting with oxygen, we saw 36.6 grams of ethanol reacted with the 63.8 grams of oxygen. Oxygen was the limiting reactant, and we were able to produce a maximum amount of 58.6 grams of carbon dioxide. That's the theoretical yield. The actual yield would be the yield of products that you would actually obtain in the real world. So let's say that you're doing this chemical reaction and you spill some of your ethanol, or the reaction doesn't go 100% to completion. That will produce a yield that's lower than our theoretical. And our actual yield is almost never 100%. It's almost always going to be lower than what we could theoretically make. So we need to determine a percentage yield. How effective were we? To do this, we take our actual yield, divide by our theoretical yield, multiply by 100%. So, for example, from the previous question, let's say that we only made 50 grams of carbon dioxide from the reaction. What would be the percent yield? To do this, we take the 50 grams, which is our actual yield, divide by our theoretical yield, multiply by 100%, and we saw that we were 85.3% effective at making our product. It's really that simple. Now, here's a problem for you to try. I'd like for you to pause the video and read over this problem and try and determine for yourself what would be the percent yield of the reaction, given the starting amounts and the actual yield. Welcome back. So the first step for this problem is for you to identify what's our balanced chemical equation. To do this, you should be able to have predicted that we had lead nitrate reacting with 2 molecules of potassium iodide to produce lead iodide solid and 2 molecules of potassium nitrate. That's our balanced chemical equation. Now, let's determine from that how much our theoretical yield would be for the lead iodide. In order to do this, we need to account for both the balanced chemical equation and the actual amounts that we have. So what do we actually start with? We start with 100 milliliters of lead nitrate. Or excuse me, 100 milliliters of potassium iodide. And we have an excess of the lead nitrate. So we know already then that our potassium iodide is going to be our limiting reactant. We still, though, need to determine how many moles of potassium iodide we have. So how do we determine the number of moles? Well, you should recognize that this is an aqueous solution. For aqueous solutions, if we take the volume and multiply by the concentration, we can get the number of moles. So to find the number of moles, we need to use the molarity. And we have 150 millimolar of potassium iodide. Take and multiply the volume by the molarity to get the moles. Make sure that you account for the fact that your volume is in milliliters and your molarity in millimolar. So you need to convert those units first. After you've done that, you would see that you have 0.015 moles of potassium iodide. Now, how much lead iodide do we make? Since the potassium iodide is our limiting reactant, we can use that value directly. So our lead iodide produced is simply calculated from the moles of potassium iodide and then using the balanced chemical equation. 2 moles of potassium iodide would produce 1 mole of lead iodide. That means that we have 0.0075 moles of lead iodide. And that would be equal to then our final moles. What is our final mass? To find the mass, as we've seen already, we multiply moles by the molar mass. Molar mass of lead iodide is 461 grams per mole. Which means that we would produce 3.46 grams of lead iodide. This is our theoretical yield. All right, now to find the percent yield, we take and the ratio of our actual over our theoretical times 100%. And our actual yield is 3.29 grams. Theoretical yield is 3.46 grams times 100%. That's going to be equal to 95.2%. Okay, that's it for this video. Thanks for watching. Have a great day.